Now in this lecture, I have combined all methods that we have created for linear queue using array in our previous lectures. Now here, we have combined all methods together to see the big picture of time and space complexity of these methods over here. Now, first method is creating queue. Now when we are creating queue, the time complexity for this operation is O1 because here we are just instantiating the array in the memory. Now when we are instantiating the array in memory, we are setting size to it. So based on this size, space complexity will be On. If we are setting the size as n, so the space complexity will be On, because when we are declaring the queue, we are allocating n number of contiguous cells in the memory. So that's why space complexity is O1. Now the next method is enqueue method. Now enqueue method inserts the elements at the end of the queue. So this means that by using top of queue variable that we have declared in our queue class, we can easily identify the end of queue. So if we can easily identify the index of end of queue, so this means that we can easily update that index cell. So this means that update the cell value based on the index takes O1 time complexity. So here enqueue method takes O1 time complexity. Now the space complexity is obviously O1 because here we are just updating the existing cells value. So that's why an extra space is not required over here. So it takes O1 time complexity. Now when it comes to dequeue method, in case of dequeue method, we are always accessing the beginning of queue and returning that value and deleting that value from the queue over here. So this means that in memory, we are not deleting it. We are just changing the beginning of queue and the value stays in the arrays. And by updating the beginning of queue property in the queue class, we are just changing the beginning of queue. So this operation will take O1 time complexity because here we are just accessing the cell value based on the index that we have already declared. So that's why it takes O1 time complexity. Now the space complexity is also O1 because here we are just changing the beginning of queue. Now the next method is pick method. Now pick method returns the first element from the queue without doing operation. So based on the beginning of queue index, we can easily return the first element from the queue. So we know that accessing an element in the array will take O1 time complexity. So that's why returning first element in the queue takes O1 time complexity. Now the space complexity is also O1 because here we are not doing any space consuming operation. Then the next method is empty method. So how can we identify that if linear queue using array is empty or not? So as we said before, based on the beginning of queue property, we can easily identify it. So if the beginning of queue points to the -1, it means that this queue is empty. So this means that based on this property, we can identify it. So here we are not performing any time consuming operation. So that's why it returns O1 time complexity. Now the space complexity similarly is O1 because here we are just checking the beginning of queue and based on that we are returning true or false, and this is not space consuming operation. Now same rules are applicable for isFull method because we are identifying it based on the top of the queue. So that's why this will take O1 time complexity. So space complexity is also O1. Now when we are deleting entire queue, in case of linear queue using array, in this case we are just setting the array to null. So that's why it will take O1 time complexity. So when we are setting array to null, we are not doing any space consuming operation. So this one also will take O1 space complexity. So with this we have come to the end of this lecture. So till this lecture we have learned how can we implement linear queue using arrays. Now in the next lecture we are going to start to learn another type of queue, which is circular queue. So see you in the next lecture.